Welcome students. In this video, I am going to explain measurement of time and simple pendulum. Pendulum clocks is used to note the time, which is based on the periodic oscillation of pendulums. So, let us first learn what is simple pendulum. Simple pendulum consists of a string which is inextensible, massless and perfectly flexible. The string is fixed with a rigid support with one end and one other end is free, and it consists of a point mass called bob. Like this is the rigid support and a string is fixed through this rigid support, and the other end consists of a point mass called bob. This is a simple pendulum. Now, to understand more about simple pendulum, we will learn certain terms related to simple pendulum. The first term is oscillation. What is oscillation? The to and fro motion about the mean position is called oscillation. Look at this. Suppose this is point S and this is point O. OS is called the mean position. If this bob is displaced to a point A, and if it is released from point A, it will start oscillating like this. It will reach to the point B and then again back to point A. So this to and fro motion about the mean position is known as oscillation. Next term is time period. We used to denote it with capital T, time period. We can define time period as it is the time taken to complete one oscillation or time taken to complete one to and fro motion. Third point is frequency. We used to denote it with F, small f. What is frequency? The number of complete to and fro motion in 1 second is called frequency, or we can say that the total number of oscillation in 1 second is called the frequency of the simple pendulum. Now we can talk about the relation between time period and frequency. So let us see relation between time period capital T and frequency F. As I said, or we will first consider, let capital T is equals to time period. I said children, time period is the total time to complete one oscillation. It means if T is the time period, it means in T seconds number of oscillation is equals to 1. Or therefore we can write in 1 second number of oscillation is equals to 1 by t. As I define, frequency is equals to total number of oscillation in 1 second, and here we get in 1 second number of oscillation. So this is called the frequency. F is equals to 1 by t. So this is the relation between time period and frequency. We can also talk about the SI unit of time period. The SI unit of time period is second, as it is time, and the SI unit of frequency, if as we have just seen, F is equals to 1 by t. So and time period unit is second, so 1 by second. So frequency SI unit is equals to per second, or we used to write with hertz, Hz, hertz. So SI unit of frequency is hertz. We can also talk some other terms related to simple pendulum, that is amplitude. Amplitude is the total distance, or we can say that amplitude is the maximum displacement on either side from its mean position. When the bob displaces during its motion, so the maximum displacement on either side is called the amplitude. So this distance OA is known as the amplitude. One more point, that is effective length of pendulum. We used to denote it with small l. So what is the effective length, or sometimes we used to say length of pendulum. So length of pendulum is the distance from the point where it is fixed, that is at the rigid support, as to center of the bob. So this length is known as the effective length of the pendulum. So effective length of pendulum is the OS distance, or distance from the fixed support to the center of the bob is known as the effective length of the pendulum. We used to denote it with small l. Now children, these are the certain points I talked about the terms related to simple pendulum. The first one I talked about, the first point was I said that oscillation, to and fro motion about the mean position is called oscillation. Second, time period, it is the time taken to complete one oscillation. Third point, I talked frequency, that is total number of oscillation in 1 second, that is frequency. Fourth point, I talked about amplitude, it is the maximum displacement on either side from its mean position. And the fifth point, I talked that what is the effective length of the pendulum. So effective length of pendulum is the length from the rigid support to the center of the bob. If we will draw a graph between square of time period and the length, graph showing variation of t square, or we say square of time period, square of time period with the length or effective length small l of pendulum. If we will draw a graph showing the variation of t square. So let us two axis, y axis which represents the square of time period, and x axis is representing the length. If we will draw a graph for different lengths of pendulum, we will get different time periods. When we will draw a graph, we will get a straight line graph. And these graphs, the slope of this graph, if we will calculate, we will get a constant. Means how we can find the slope of this graph? To find the slope of this graph, let us draw two perpendiculars. This is the length, so I am writing L1. Another perpendicular, L2, and this side one more perpendicular, T1 square, and from there T2 square. If we will complete the triangle, suppose PQR, let this angle is theta. Then if we want to slope of this line, then we can write slope is equals to tan theta, or tan theta, as you know, perpendicular by base. So we can write perpendicular in this is PQ and base is RP. So we will get it. PQ means this distance. This distance is total is T2 square and this one is T1 square. So this distance will become T2 square minus T1 square, and this is RP. RP we can calculate. Total distance is L2 minus L1. This we will get a constant. The value of this constant is this graph shows the variation between t square and L, and the slope what we will get, that will be a constant as it is a straight line. Okay, so let us see what is the value of this constant. If I will write this constant value, so value of this constant I am just writing it as a k. So k is equals to, we are getting 4 pi square by g, where 4 is a constant, pi 3.14, and g is acceleration due to gravity, whose value is 9.8 meter per second square. So this constant we are getting from the slope, or I can write like this. Slope is equals to a constant, I said 4 pi square by g, or we can say g is equals to 4 pi square by slope of t square versus L graph. So this is the one formula by which we can calculate the value of small g, acceleration due to gravity. Again, as I show that graph, and in that graph I show that the graph was just like that, t square, and this side was L, and I draw like that. It indicates that as the length is increasing, so time period or square of time period is also increasing. Okay, so we can write an expression for time period of simple pendulum. We do not have to derive that formula, we will write directly time period of simple pendulum. time period of simple pendulum. This t is equals to, as I said, time period or square of time period is directly proportional to length. As from graph we have calculated that, or I said t square is equals to KL, or t square is equals to k is the proportionality constant, and k value we can write 4 pi square by g into L. Therefore t is equals to 4 pi square by g into L, or we can write therefore t is equals to, time period is equals to 2 pi root under L by G. This is the expression for time period of simple pendulum. We will use this expression for solving different types of numericals. Now I will explain one more point on this formula only, that is, I will talk about the factors affecting the time period. Factors affecting the time period of simple pendulum. So there are certain factors which affects the time period of simple pendulum. As we have just learned the formula, t is equals to 2 pi root under L by G. From there if we will see, then first factor is the length L. How the length affect the time period? We can see that t is directly proportional to the square root of length. So as the length will increase, time period will also increase. The second point is acceleration due to gravity. Acceleration due to gravity, that is small g. We can see from the formula only, t is inversely proportional to the square root of g. So as the g will increase, time period will decrease. As the g will increase, time period will decrease. Means if the value of t, as you know that g is acceleration due to gravity and its value is fixed 9.8, but it changed due to the earth is not an exact spherical. Earth shape is also like a oval, so value of g differs from place to place. Like on equator, the value of g is very low, minimum, and at the poles the value of g is maximum. The value of g at the poles is maximum. So if g will be greater, so time period will be smaller. Now we can see the third point, mass of the bob. As in this formula there is no mass factor is there, so the time period of simple pendulum is independent of the mass of the bob. The time period of simple pendulum is independent of the mass of the bob. One more factors we can talk, that is amplitude. The time period of simple pendulum does not depends upon its amplitude. Means if you will displace this point bob from O to A, or you will displace it to the point B, so what will be its displacement? There will be no effect on its time period. The time period will be same as you will release the ball or bob from point A or from point B. It will be, the time period will be always same in all the case. So children, we can understand amplitude, no effect on the time period. Mass of the bob, no effect of the time period. acceleration due to gravity, as we have seen that inversely proportional to the square root of time period is inversely proportional to the square root of acceleration due to gravity, and the length time period is directly proportional to the length of the pendulum. We can also see one more thing, one more type of pendulum we have, that is called the seconds pendulum. So what is the seconds pendulum? Seconds pendulum. A simple pendulum whose time period is 2 seconds. Remember, student, a simple pendulum whose time period is 2 seconds is known as seconds pendulum. This type of pendulum having approximately the length is of 1 meter. So a pendulum whose length is 1 meter, that means their time period will be 2 seconds. Such pendulum is called seconds pendulum. Thank you, students. Thank you.